Today's session is on calculating the carbon footprint of an organization and product, like Jana said. And so let's continue our journey into understanding and managing environmental impact in a modern business, basically. So in our last session, we talked about sustainable development, ESG regulations, and the different reporting frameworks used in organizations. So we looked at how companies can align their strategies with today's sustainability expectation and show real commitment to environmental and social responsibility. So today we're building on that foundation and turning our attention to key topic in environmental management. So how to calculate a carbon footprint. In recent years, this topic has become more and more important. Climate change is no longer a distant issue. It's something we're dealing with right now. So for many companies, calculating and reducing emissions is not only required by law, but it's also a big part of running a responsible and future-ready business. So more and more organizations are realizing that understanding their carbon footprint is essential if they want to stay competitive and be seen as a truly sustainable. So the goal of today's session is to give you a clear and practical understanding of carbon footprint calculation, and why it matters in the context of organizations. We'll take a look at both theory and practical examples to give you a finished insight into the topic. By the end of this session, I hope you'll be more aware of the main ideas and how they might apply in your context. To help structure out our time together, we'll focus on the following key learning points. First one is define what a carbon footprint is and explain why it's important to measure and reduce it. Then understand the key standards and methods used to calculate it. Tell the difference between an organizational and a product carbon footprint and know how each one is calculated, and see the real benefits of managing our carbon footprint and how it supports wider sustainability goals. So the goal of this session is to give you a starting point. An overview of useful concepts and practices that can help you begin addressing carbon emissions in your organization. By building on best practices and proven approaches, you'll be better equipped to not only reduce your environmental impact, but also contribute to stronger performance and greater resilience within your organization. So what is carbon footprint? A carbon footprint is a measure of the total amount of greenhouse gases, or GHGs, emitted directly and indirectly by an activity, an organization, or a product. It is typically expressed in terms of carbon dioxide equivalents, or CO2e, which take into account the varying global warming potentials of different gases, such as methane and nitrous oxide and others. The concept of carbon footprinting emerged as environmental concerns gained momentum, particularly in the context of climate change. So as scientists began to understand the significant role of human activities and in accelerating global warming, it became crucial to develop a method for quantifying the emissions that contribute to this phenomenon. So carbon footprinting therefore became a practical tool for measuring the impact of various processes and steps, activities on the environment. Calculating a carbon footprint involves defining and quantifying all relevant sources of GHG emissions, which can include energy consumption, transportation, waste generation, production process and supply chain activities. These emissions are then converted into CO2e to provide an unified measure of environmental impact. One of key challenges when calculating carbon footprint is accurately determining the emission sources. This requires a thorough analysis of operational processes and an understanding of the broader supply chain. For example, a manufacturing company may have different emissions from on-site fuel combustion as well as indirect emissions from purchased electricity and transportation of raw materials. So to better understand carbon footprinting, it is useful to categorize emissions into three distinct scopes as defined by international standards such as the GHG protocol. The first one are direct emissions or scope 1. These are emissions that result from sources directly controlled or owned by the organization, such as combustion from companies' vehicles or on-site energy generation. Scope 1 emissions are often the easiest to measure because they come directly from the organization's own activities. For example, a logistics company would include emissions from its vehicle fleet under Scope 1. Indirect emissions from energy, this is Scope 2. These emissions are associated with the consumption of purchased electricity, heat, or steam. Although they occur off-site, they are a direct consequence of the organization's energy use. For instance, an office building using grid electricity would account for the emissions from the power plant that generates that electricity. These emissions are crucial to track as they often represent a significant portion of an organization's carbon footprint. And the last one are other indirect emissions or Scope 3. These are emissions that occur outside the organization's direct control, such as those from the supply chain, business travel, waste management, and the use of sold products. Scope 3 emissions are often the most challenging to quantify due to the extensive data required from third parties, and we will look it through. Nevertheless, they can represent the largest share of an organizational total carbon footprint, especially in industries reliant on expensive supply chain or distribution networks. For example, a retail company might consider emissions from the production and transportation of goods as part of its Scope 3 footprint. So by clearly defining these scopes, organizations can systematically assess their total carbon impact and identify areas where emission reductions can be most effectively achieved. Understanding the full extent of emissions, both direct and indirect, is essential for developing comprehensive carbon reduction strategies and meeting regulatory and stakeholder expectations. So why is carbon footprint measurement important? Measuring and reducing carbon footprints is vital for several reasons. First and foremost, it is directly addressing the urgent challenge of climate change by enabling organizations to understand the sources and magnitude of their emissions. Without accurate measurement, it is impossible to develop meaningful reduction strategies or set realistic sustainability goals. Reducing the carbon footprint not only helps mitigate environmental harm, but also brings tangible business benefits. These include compliance with regulations. So many countries and regions have introduced strict reporting requirements and emission targets. For example, EU, like we said on the last session, has established regulations under the European Green Deal. that require companies to reduce their carbon footprint significantly by 2030. Adhering to these regulations, it is crucial for maintaining operational license and avoiding penalties. Moreover, being compliant with legal requirements demonstrates an organization's commitment to responsible business practices. The next one is adherence, reputation, and competitiveness. As public awareness of climate change continues to rise, stakeholders are increasingly interested in supporting companies that demonstrate environmental responsibility. So reducing emissions can strengthen a company's brand and attract environmental conscious customers, which can also lead to greater customer loyalty and brand differentiation and in a competitive market. Operational efficiency and cost savings. Identifying emissions hotspots often reveals opportunities for improving energy efficiency, reducing resource consumption, and lowering operational costs. For example, optimizing logistics and reducing energy waste can result in substantial savings. A study by the Carbon Trust has shown that companies implementing carbon reduction measures can achieve up to 20% cost savings on energy bills. And then access to financing and investment opportunities. Investors are placing greater emphasis on environmental, social, and governance (ESG) criteria when evaluating potential investments. Companies that proactively manage their carbon footprint are more likely to attract funding and support as they are seen as lower risk and more future-oriented. So, in addition to these practical benefits, there is also an ethical dimension to carbon footprint management. Organizations that take responsibility for their environmental impact demonstrate a commitment to safeguarding the planet for future generations. So this approach is increasingly seen not only as a corporate responsibility, but as fundamental expectation of modern business practices. So before we look at how to calculate a carbon footprint, it's important that we first understand what it actually is. Put it simply, a carbon footprint is the total amount of greenhouse gas emissions caused by an activity, a product, or an entire organization, either directly or indirectly. These emissions are usually measured in something called carbon dioxide equivalents, I mentioned this before, or CO2e. This unit helps us compare different greenhouse gases like methane or nitrous oxide by converting them into the same scale based on how much they contribute to global warming. The idea of carbon footprint printing became more important as the world started paying more attention to climate change and environmental damage. So governments, companies, and individuals began to realize that if we want to reduce our impact, we first have to understand and measure it. So with the rise of international climate agreements like the Paris Agreement, carbon accounting has become an essential tool. It helps us take action in a structured, measurable way. Sorry. So let's take a closer look at the methodologies for calculating a carbon footprint. When we want to calculate the carbon footprint of a product, we can choose from several different methodologies. Each offers its own approach and level of detail. But the one that's most commonly used and considered the most reliable is the life cycle assessment, or LCA. Knowing the differences between the methods help us choose the one that best fits our goals and the specific needs of our product or business. So what is a life cycle assessment and why is it so important? LCA is a method that helps us understand the full environmental impact of a product or service throughout its entire life cycle. That includes everything from raw material extraction, production, and transport to use, disposal, or recycling. And LCA doesn't just measure carbon emissions. It also takes into account other environmental impacts like water use, pollution, and depletion of natural resources. So let's break down the four main stages of LCA. The first one is goal and scope definition. In the first step, we define the purpose of the study. Are we doing it to reduce emissions, to compare to product options? We also set the boundaries, which parts of the product life cycle we include. The next one is inventory analysis. This step is all about the data. We collect information about all materials used, energy consumed, waste generated, and emissions released across the full life cycle. The third one is impact assessment. Now we analyze the environmental impact of each stage using standardized emissions factor. The goal is to calculate the CO2 equivalent for each activity. And the fourth one is interpretation. Finally, we look at the results to identify hotspots, the stages that generate the most emissions. So this helps us decide where and how to make improvements, whether that's by changing materials, adjusting processes, or redesigning product use. So LCA gives us more than just the numbers. It gives us insight, a clear picture of where emissions came from and where we can take meaningful action to reduce them. And in the next sections, we will also take a closer look at LCA. So what's the difference between carbon footprinting and life cycle assessment? Life cycle assessment gives us a full, detailed picture of a product's impact on the environment, but sometimes we don't need the whole picture. That's where carbon footprint methodology comes in. It focuses only on the one thing, greenhouse gas emissions. This makes it simpler and more practical, especially for businesses that are just starting to measure their environmental impact, while LCA looks at all types of environmental impacts like carbon emissions, water use, pollutions, and waste. Carbon footprinting looks only at emissions, usually measured in CO2e equivalents. For example, a company might want to measure the emissions from producing and transporting one specific product. In that case, carbon footprinting would be easier and faster tool because it doesn't go into things like water usage or raw material depletion. So to sum it up, the LCA is broader. It covers all environmental impacts. Carbon footprinting is more focused. It looks only at greenhouse gas emissions. Both methods are useful. It just depends on what you're trying to achieve. So now let's take a talk about the difference between organizational and product carbon footprints. If a company wants to take sustainability seriously, it first needs to understand what kind of carbon footprint it's looking at. There are two main types, the organizational carbon footprint and the product carbon footprint, and each of them serves a different purpose, focuses on different areas, and gives us different insights. Knowing the difference helps businesses create more focus and effective strategies for reducing emissions. So what is organizational carbon footprint? An organizational carbon footprint measures the total greenhouse gas emissions that comes from companies' activities. This includes emissions from production, transport, energy use, and even the wider supply chain. It gives us full picture on how the company as a whole impacts the environment. And why is this important? So for sustainability reporting, obviously, to share progress with internal teams and external stakeholders. Then for regulatory compliance, especially as legal requirements are getting stricter, and for tracking progress to measure how well the company is doing and in reaching its climate goals. So organizational carbon footprints are broken down to 3 categories, which we mentioned. The first one is Scope 1, direct emissions, Scope 2, indirect emissions from energy, and Scope 3, the indirect emissions. This broad measurement allows businesses to assess their overall environmental footprint, helping them to prioritize their emissions reduction efforts and set high-level sustainability goals. So what about product carbon footprint? The product carbon footprint, in contrast, focus on the emissions associated with a specific product or service across the entire life cycle, from raw material extraction throughout manufacturing, transportation, use, and end-of-life disposal. And this type of footprint provides a more granular view of the environmental impact of individual products, helping organizations understand how their offerings contribute to the global emissions. What is it used for? Useful for product labeling provides consumers with clear information about the environmental impact of the products they buy. Product carbon labeling can drive consumers' awareness and encourage more sustainable purchasing decisions. Then eco-design, helping businesses design products with lower carbon footprints by identifying high emission stages in the product life cycle. By improving the design and material selection, companies can reduce the product's overall environmental impact. And supply chain optimization, identifying emissions hotspots in the supply chain, such as transportation, raw material sourcing, or packaging. This allows businesses to work with suppliers to optimize processes and reduce emissions. For example, a food processing company may calculate its organizational carbon footprint to understand emissions from its production facilities, logistics, and administrative activities. At the same time, the company might calculate the product carbon footprint of its packaged food items to evaluate the emissions associated with sourcing ingredients, processing, packaging, transportation, and waste disposal. So let's put this into a real example. Imagine a food processing company, like we said. On the one side, they calculate their organizational footprint to measure emissions from their factories, logistics, offices, and entire operation. And like we said, at the same time, they calculate the product footprint for specific packaged food. So both measurements are important, but they serve different goals and lead to different types of actions. So why is it important to know this difference? If a company wants to seriously tackle its emissions, it needs to know the difference between its overall footprint and the footprint of its individual products. Otherwise, it's hard to know where to start or what to improve. The organizational carbon footprint, like we said, provides an overarching view of companies' environmental impact, and it is crucial for setting corporate level goals, for identifying high-level opportunities to improve sustainability, such as optimizing energy use or reducing emissions at the supply chain. The product carbon footprint, on the other hand, allows organizations to evaluate the environmental impact of individual products, enabling them to make targeted improvements in produced design and sourcing. By understanding which products have the highest emissions, businesses can focus on reducing the carbon footprint of specific items, which may involve redesigning products, switching to more sustainable materials, or improving logistics. So by differentiating between these two types of footprints, businesses can better align their carbon reduction efforts with specific sustainability goals. So the organizational footprint helps improve operational efficiency at the company level, while the product footprint provides insight into how to enhance the sustainability of individual products or services. And both footprints are essential for driving a company's overall sustainability strategy and achieving meaningful carbon reduction. So understanding both is critical for developing a comprehensive sustainability strategy, making informed decisions about emission reductions, and aligning efforts with broader environmental goals. So let's talk about standards behind carbon footprint calculations. So to measure a carbon footprint properly, we need more than just data. We need structure and consistency. That's where international standards and methodologies comes in. These standards help organizations make sure their calculations are accurate, comparable, and credible, no matter the industry or country, as they act as global guidelines, helping businesses navigate the often complex process of carbon accounting. So more importantly, they allow for transparent reporting, which is key when communicating with stakeholders, regulators, or customers. By using these well-established frameworks, companies can confidently measure and report their emissions, show accountability and commitment to sustainability, and stay aligned with both regulatory requirements and market expectation. Using standard methodologies also improves the quality of data, which leads to better decisions and supports continuous improvement in carbon management. And of course, it helps build trust. Businesses that follow these standards are seen as more reliable, proactive, and future-ready. So which standards are we talking about? The most widely used standards for calculating carbon footprints are before mentioned Greenhouse Gas Protocol, then ISO 14064, 14067, and 14068. So let's start with the GHG protocol, the global standard for carbon accounting. The GHG protocol is the most widely used and globally recognized standard for measuring greenhouse gas emissions. It was developed by two big organizations, the World Resources Institute and the World Business Council for Sustainable Development. What is its main goal? Well, to help businesses calculate and report their emissions in the clear, structured, and internationally accepted way. One of the key features of GHG protocol is that it splits emissions into three categories, which we mentioned, and we will several times again. These categories are called pillars or scopes, scope 1, scope 2, and scope 3. The GHG protocol is widely used by companies around the world, especially when they prepare sustainability reports or need to comply with regulations. It also provides tools and templates to help organizations to do their calculations correctly and consistently, which makes it a solid foundation for any serious carbon management strategy. So now let's take a look at ISO 14064, the standard for organizational carbon footprints. While the GHG protocol is widely used, many companies also turn to ISO 40064, a well-known international standard that focuses specifically on the carbon footprint of the entire organization. The standard lays out clear principles, requirements, and guidelines for how to measure, report, and manage greenhouse gas emissions at the organizational level. It also goes further by covering important topics like how to verify and validate your emissions data, how to account for emissions reductions, and how to ensure full transparency and accountability in your carbon reporting. And like GHG protocol, ISO 40064 uses the same three scopes to categorize emissions, scope 1, 2, and 3. Following ISO 40064 helps companies build trust with stakeholders, improve the credibility of their carbon reporting, and stay aligned with regulations and reporting platforms. So in many cases, this standard is not just recommended, it is actually required by regulatory frameworks or industry guidelines. And by using ISO 14064, companies are in much better position to manage their emissions, track progress over time, and meet their climate-related commitments. Now let's take a look at ISO 40067, the standard for product carbon footprint. This standard focuses on the organizations as a whole. The standard before focused on the organization as a whole, but this standard is all about individual products. So it helps companies measure and communicate the carbon emissions linked to a specific product from start to finish. And that's really important for businesses that are working on eco-friendly design, for example, transparent labeling, and meeting the growing demand for sustainable products. So this standard is based on principles of life cycle assessment, which means it looks at the entire life cycle of a product that includes raw material extraction, production, packaging, transportation, product use, and end-of-life disposal. And by using this standard, companies can get detailed breakdown of where emissions are coming from at each stage, and more importantly, where they can be reduced. For example, they might identify opportunities to improve production by lowering energy use or switching to cleaner technologies. Then packaging by using recycled or lighter materials. Transportation by optimizing routes or using lower emission vehicles, and end-of-life management by making products easier to recycle or designing them to last longer. So ISO 14067 gives companies the insight they need to design more sustainable products, reduce emissions, and offer clear, credible information to consumers. It also allows them to participate in eco-labeling programs, which are becoming more and more important in a market where customers want to make climate conscious choices. So what about ISO 14068, the standard for carbon neutrality? The goal of this standard is to help organizations follow the credible and consistent approach when they want to go carbon neutral, whether that's for product or service or the whole company. So what does it cover? It focuses on 4 key areas. The first one is measuring emissions. Just like the other standards, it starts with accurate measurements across the full life cycle of a product or an organization. Reducing emissions, then it pushes for real reductions through things like energy efficiency, switching to renewables, and improving processes. Offsetting residual emissions. After all possible reductions, some emissions will still remain, and ISO 14068 outlines how to compensate for those using carbon credits or carbon sink projects like reforestation or soil carbon initiatives. And verification and transparency, obviously, one of the most important parts. The standard emphasizes independent verification and clear, transparent communication. If a company claims to be carbon neutral, that claim needs to be backed up with solid data and third-party confirmation. So by following ISO 14068, organizations can show that their carbon neutrality efforts are serious, measurable, and credible. It builds trust with stakeholders, strengthens the company's reputation, and can even boost competitiveness in markets where climate action really matters. So understanding the methodologies, why it all matters. As we've seen, accurate and consistent carbon footprint calculation is key element for any organization that's serious about reducing its environmental impact and achieving long-term sustainability goals. So using internationally recognized standards and methodologies ensures that our approach is not only technically sound, but also transparent, comparable, and aligned with market and regulatory expectations. Following these standards, it's much more than a compliance exercise. It's about building a reliable foundation for climate action, supporting informed decision-making, and communicating sustainability efforts in a clear and credible way. So for organizations, this means not only responding to expectations, but actively positioning themselves as forward-thinking, responsible, and resilient in a low-carbon economy. So let's look at units and indicators used in carbon footprint calculations. When we calculate a carbon footprint, the results are usually expressed in a unit called CO2 equivalents or CO2e. This unit is essential because it allows us to combine different greenhouse gases into one single comparable value. So why do we use CO2e? Different greenhouse gases don't all have the same effect on global warming. Carbon dioxide, CO2, is the most common, but methane and nitrous oxide are actually more powerful in terms of their warming effect per kilogram. And to make comparisons easier and more meaningful, we convert all of these gases into the same unit, CO2 equivalents. This way, we have a standardized, universal metric to express the total climate impact, no matter which gases are involved. But what about global warming potential, or GWP? Well, this is the factor we use to make that conversion. It tells us how much heat a greenhouse gas traps in the atmosphere over a certain time period, usually 100 years compared to the CO2. So to understand why we use CO2 equivalents, it helps to look at some of the most important greenhouse gases individually and compare their global warming potential, or GWP. We mentioned carbon dioxide, CO2. This is the most common greenhouse gas caused by human activity. We mainly release CO2 by burning fossil fuels like coal, oil, and natural gas. And it's also the reference point for all other gases with a GWP set to 1. Then we have methane. Methane is much less common in the atmosphere than CO2, but it's far more powerful when it comes to trapping heat. Over 100 years period, methane gas has GWP of 25. That means 1 ton of methane has the same warming effects as 25 tons of CO2. Methane mostly comes from agriculture, like livestock, landfills, and fossil fuel production. Nitrous oxide, this gas comes mainly from agriculture, especially from fertilizers and soil management, and it's even more potent than methane. Its GWP is 298, so 1 ton of NO2 has the same warming effect as 298 tons of CO2 over 100 years. And then we have fluoro integrated gases. These are, we have one question. Or
Yes,
should we
hi.
continue? Hi.
Just a short question. So basically, so we know that carbon dioxide was emitted from many of the countries or industries or for the automotive applications as well. But so for the nitrous oxide and the fluorinated gases are also more quantity in Europe, or it's less? I mean, from the.
Sorry, I didn't understand. The question
I
is
mean,
it the CO2 the biggest problem in Europe or every other gas?
no, I know CO2 is the biggest problem, but also
Yeah.
is the same like nitrous oxide and fluorinated gases are also like the same. It's emitting a lot, or it is less compared to the CO2.
Well, this is a tricky question, but to answer it, that's why important we have the right methodology when calculating CO2e equivalent or carbon footprint, because we have to know what our organization has in the means of carbon footprint, all the technologies that we use. Because, for example, I just wanted to mention fluorinated gases. These are used in refrigerator, air conditioning, and various industrial procedures or processes. And that's why it's important that we measure everything in our organization that can contribute to the CO2 or carbon footprint. That's why we use not just carbon dioxide, but carbon dioxide equivalent, because all these gases are combined.
Okay, okay. So do you
Okay.
have a percentage graph, something like this?
Percentage graph, I don't think I have in this presentation,
Okay.
but maybe in the further presentation, I will answer hopefully some questions. But either way, you can write me and I will look on it if you need if you have specific questions that will not be answered through our presentation today.
Yeah, thanks. Yeah.
Okay, thank you very much. It's nice to know that you are really listening to me, because online sessions can be a bit tricky for Rectular. So yes, let's move on. Like I said, fluoro-integrated gases, these are synthetic gases that are used in things like refrigerator, air conditioning, we all have basically, and various industrial processes. And even though they're released in smaller quantities, they are have extremely high GWPs. For example, one sulfur hexafluoride has GWP of 23,500. So that means that 23,500 times more powerful is than CO2 when it comes to trapping heat, and it is, I believe, in the air conditioning systems. So this is exactly why we use CO2e, because it lets us bring all these very different gases into one same scale. It's not just about carbon dioxide, what we can basically hear every day. No, it's CO2 equivalent. It's the carbon footprint calculation. So this way, companies can express the total climate impact of their activities or products using a single consistent metric, which making it much easier to compare, report, and manage emissions effectively. So why do we use CO2e in carbon footprinting reporting? Let's wrap it up. So we've seen how different greenhouses vary in strength. And the next question is, why do we express everything in CO2 equivalents? Well, the simple answer is it works. Using CO2e helps organization communicate their emissions in a way that that's both accurate and easy to understand. And here are three key reasons why CO2e is important in carbon footprint reporting. First, it allows for standardized comparison. So every organization or product emits a mix of greenhouse gases. By converting all those emissions into CO2e, we make them comparable, no matter whether it's what type of gas is involved. And that means stakeholders, whether it's customers, investors, or regulators, can easily compare the environmental impact across different companies, products, or activities. And then it simplifies communication. Instead of listing a mix of complex gases with different effects, companies can report everything in one single clear metric. And this makes sustainability reports more accessible and easier to follow, especially for non-technical audiences. And it aligns with global standards. Major frameworks like GHG protocols and also mentioned previously ISO standards all use CO2e in the common unit as the common unit. By following the approach, businesses ensure their reporting is consistent, credible, and in line with international best practices, which also helps meet regulatory and investor expectations. So CO2e is more just a unit. It is a language of carbon reporting, and it plays a key role in making climate data both usable and trustworthy. So now let's talk about how carbon footprint results are usually presented and why tons of CO2e are used as the standard unit. So when company calculates its carbon footprint, the results are typically expressed in tons of CO2e. And this unit helps both the organization and its stakeholders like customers, regulators, or investors easily understand the total impact of emission. It doesn't matter if the emissions comes from a product, a company or a company's operation, or the entire supply chain. They're all shown using the same unit. For example, if company calculates the carbon footprint of a product, the result might be something like, this product has a carbon footprint of 0.5 tons of CO2e. That number reflects the total emissions linked to that product, including all greenhouse gases across the entire life cycle, from raw material extraction through production and transport, all the way to use and disposal. Now, why is this important? So using CO2e as the standard unit helps organizations in several ways. First, it makes it easier to compare products. When everything is measured in CO2e, businesses can clearly see which products have higher emissions and where it makes sense to focus on improvements. Second, it helps with tracking emissions over time. If a company wants to reduce its footprint, it needs to measure progress, and CO2e gives a consistent way to show reductions both in internal reporting and in public sustainability reports. And third, it supports alignment with global climate goals, such as Paris Agreement, which aims to limit global warming to below 2 degrees Celsius. So to contribute meaningfully to such targets, organizations need a clear and standardized way of calculating and reporting their emissions, and that's why exactly why CO2e what provides. So to sum it up, CO2 equivalent is a key metric in carbon accounting because it brings together the warming effects of all greenhouse gases into the comparable value. And it makes communication clearer, reporting more consistent, and decisions easier to base on actual data. And most importantly, it allows companies to make informed choices on how to reduce emissions, improve their environmental performance, and move in line with global sustainability expectations. Sorry, just a moment. Okay, so let's now look at why managing an organization's carbon footprint is so important, not just from a technical point of view, but as a core part of modern business strategy. As awareness of climate change continues to grow, expectations from stakeholders are also rising. So customers, investors, regulators, and even local communities increasingly expect companies to make responsibility or responsibly to take responsibility for their emissions and to actively work on reducing them. We can look at the importance of carbon footprint management through several key perspectives. So risk management and regulatory compliance. One of the main reasons organizations focus on managing their carbon footprint is to reduce risk, both in terms of climate-related threats and regulatory pressure. Around the world, environmental regulators are becoming stricter. Not complying with them can lead to legal penalties, fines, or even reputational damage. Take the European Green Deal, for example. It aims for net zero emissions by 2050, and that places serious demands on many industries. By managing their emissions proactively, companies can stay ahead of regulators, adapt to upcoming changes, and ensure compliance. And this reduces the risk of sanctions and at the same time strengthens their image as a responsible corporate actor. Then brand reputation and stakeholder trust. Today, more and more consumers and businesses partners prefer to work with companies that show real commitment to environmental responsibility, because having a clear and transparent carbon footprint strategy helps build trust and loyalty among stakeholders. And on the other hand, companies that ignore their climate impact risk losing consumer confidence and demanding their brand. So those that do act can even gain competitive advantage. Then business continuity and operational efficiency. Managing emissions isn't just about external pressure, it also leads to real internal benefits. By analyzing emissions, companies often identify areas where they can improve efficiency, reducing energy use, cut down on waste, and optimize their processes. This results to lower operating costs, better productivity, and greater resilience, especially as energy prices continue to rise. And investor and financial community expectation, basically we can't ignore the growing influence of investors and the financial sector. More and more investors are using ESG criteria when assessing companies. They understand that businesses which actively manage their carbon footprint are better prepared for climate-related risks, and frameworks like the Task Force on Climate-Related Financial Disclosures are encouraging companies to be more transparent about their emissions and carbon management strategies. Companies that disclose their emissions and show clear efforts to reduce them are seen as more resilient, better governed, and future ready, and are therefore more attractive to investors. So let's now talk about, let's look at some of the challenges and opportunities that come with calculating a carbon footprint. So even though the benefits of managing carbon emissions are clear, the process of calculating them, especially for an entire organization, can be quite complex. Here are some of the most common challenges that companies face. So first is data availability and accuracy. This is one of the biggest difficulties, and it's simply gathering the data. To calculate emissions currently, companies need reliable data from many different sources. This becomes even more difficult when dealing with indirect emissions or scope 3, which often involve external suppliers and partners. For example, data from the supply chain might be incomplete, inconsistent, or even entirely unavailable, making it hard to estimate the total carbon footprint. So to improve this, many companies are now turning to digital tools and data platforms that help centralize and automate data collection. Another important step is to collaborate with suppliers to improve transparency and get better quality data, especially for Scope 3 reporting. Then the next one is complexity of Scope 3 emissions. Scope 3 emissions are often the largest part of companies' total footprint and also the hardest to measure. They come from the sources that the company doesn't directly control, such as upstream activities like raw material extraction and production, and downstream activities like product distribution, use, and disposal. And because these emissions are complex and difficult to quantify, many companies either underestimate them or leave them out entirely. But that creates major gaps in reporting and leads to an incomplete or misleading carbon footprint. So even though Scope 3 is challenging, it's critical that organizations make the effort to include it because it gives a much more realistic picture of their climate impact. And standardization and methodology selection. This is also a challenge, which methodology to choose. So with so many different activities and processes, especially in companies with global operations, it can be hard to apply a consistent approach. So that's why using internationally recognized standards like we talked about, these are GHG protocol, ISO 14064, 67, and 68 are so important. They provide a reliable framework and help ensure that reporting is consistent and comparable. However, interpreting these standards correctly and applying them to the specific context of a business can be daunting. To address this, many organizations work with carbon accounting experts or use established calculation tools that are already aligned with global standards. Training internal teams also play a big role. It helps ensure that everyone understands the methodology, that the data is applied correctly and consistently. So let's now turn to how we actually calculate the carbon footprint of an organization. This is a complex process, but also an essential one because it gives companies a clear understanding of the environmental impact of their operations. Today, organizations are under more pressure than ever, we all know, to reduce their emissions and to show the real environmental responsibility. And that's why accurate carbon footprint calculation has become a core part of modern business management. But the motivation isn't only legal. Yes, there are growing regulatory requirements, but just as important are the rising expectation from stakeholders, customers, investors, employees, and even local communities. So reducing emissions is no longer just about ticking a compliance box. It is also about staying competitive, protecting and growing brand reputation, and contributing meaningfully to global climate goals. And when organizations systematically measure their greenhouse gas emissions, they can see where emissions are the highest, identify opportunities to reduce them, and create target strategies to improve. That doesn't just help with regulatory compliance, it also positions the company as proactive, responsible, and future-oriented. So why does calculating the carbon footprint of an organization really matter? Well, the answer is simple. Without good data, we can't manage emissions effectively. But with accurate carbon footprint data, organizations can take actions in smart and targeted way. Here's what accurate calculation allows us to do. First, identify major emission sources. When you know where emissions are the highest, we can focus on reduction efforts on the areas that matters most. Then set realistic and measurable goals, very important. With clear data, it becomes much easier to set achievable targets that align with the organization's sustainability strategy. Then enhance operational efficiency. Often the same areas that generate high emissions are also inefficient. But improving these, companies not only cut emissions, but also save costs. Meet stakeholder expectation. Transparency around carbon emissions is now a key demand for customers, investors, and regulators. And organizations that communicate openly and take responsibility are more likely to earn trust and support and improve decision-making. Data-driven insights help companies to make better choices when it comes to resource use, technology, and supply chain management. We must also talk about emission factors, a basic but essential part of carbon footprint calculation. Emission factors are used to estimate how much greenhouse gas is emitted for a specific activity or type of consumption. Put it simply, they allow us to convert activity into emissions. For example, if we burn 1 liter of diesel, or use 1 kilowatt hour of electricity, an emission factor tells us how much of CO2 equivalent that actively produces. Because it's often not practical or affordable to measure emissions directly, we use these standardized factors to estimate emissions indirectly based on reliable data. Emission factors are developed from scientific research, industry data, and national or international reports. They are essential tool in making carbon footprint calculation accurate and consistent. So why are so important? There are several key reasons. First, they standardize the calculation process. This means different organizations can calculate their emissions in the same way, making the results more reliable and easier to compare. Second, they improve efficiency. Direct measurements of emissions can be complex or expensive, especially across the entire organization or supply chain. Emissions factors make it much simpler to get responsible, accurate estimates. Third, they provide reliable results when we can't measure everything precisely. That's especially useful in large or complex systems. Fourth, they support compatibility. When everyone uses the same method, results can be benchmarked across different industries, sectors, or even countries. And finally, they support transparency. Emission factors makes it possible to trace how we got to specific number and help build trust in reporting. So without emission factors, it would be extremely difficult, if not impossible, for organizations to calculate their emissions properly, especially in a complex supply chain or global operations. So in short, they're a practical and scientifically sound way to make carbon footprint data meaningful and usable. So how are emission factors actually determined? These factors don't come out of nowhere. They're based on empirical data, scientific research, and validated industry practices. There are a few main sources that are typically used when emissions factors are calculated. First, we have fuel combustion data. This includes direct measurements of greenhouse gas emissions from burning specific fuels like diesel, gasoline, or natural gas. Then we have life cycle assessment. These studies look at the emissions produced through the entire life cycle of a product, from raw material extraction to production to transport, use, and final disposal. Another important source is national inventories. Governance and international organizations like IPCC regularly publish reliable data that's used to define standard emission factors for different regions and sectors. And finally, there are industry-specific studies. Sometimes emission factors comes from specialized research carried out by industry association or environmental agencies, especially when the data needs to be very specific to a certain sector. Emission factors are expressed in different units depending on the type of activity. Some common examples include kilograms of CO2e per kilowatt hour for electricity use, energy use, then kilograms of CO2e per liter for liquid fuels and diesel or gasoline, CO2e per kilometer for transportation-related emissions, and CO2e per ton of material product for emissions linked to industrial processes. These units also allow us to take everyday activities like using electricity, fueling a car, or manufacturing a product and translate them into climate impact using a single corporate metric. That's how we move on from raw data to meaningful carbon footprint results. And now we will take a look on how to choose the right emission factor, because the accuracy of carbon footprint calculation depends heavily on this step. There are few important things to consider when selecting emission factors. First, the reliability of the data source. It's essential to use emissions factors from credible and reputable sources. Some of the most commonly used are the Intergovernmental Panel on Climate Change, or IPCC, which provides global and regional emission factors. The EPA, which offers detailed factors for different fuels and industrial processes, and DEFRA, which is especially well known for emissions factors related to fuel combustion and waste. And of course, many countries also publish their own national databases with verified and up-to-date emission factors. And I believe that the last slide of this presentation, I gave you the links to these sources. So second, regional relevance. Emission factors are not the same everywhere. They can vary a lot depending on how energy is produced and what types of fuels are used. For example, electricity generated from coal in Poland has a much higher emission factor than electricity from hydropower in Norway. So these differences also reflect fuel quality, technology, and efficiency of combustion. So when possible, it's best to use region-specific emission factors that reflect local conditions. And third, industry specificity. Some industries, especially those with complex manufacturing or heavy processes, have specialized emissions factors. Whenever available, use data that is specific to your sector or activity that ensures your calculations are accurate and relevant as possible. And fourth, recency. Emission factors can change over time, especially as the energy mix evolves or as new data become available. So always check the date of publication and make sure you're using the most recent version. In short, choosing the right emissions factor isn't just about picking from a list. It requires looking at the source, the region, the industry, and the timing. It's one of the most important steps for ensuring that your carbon footprint data is both accurate and credible. To make the idea of emission factors a bit more concrete, let's look at some real-world examples from different sectors and regions. Let's start with electricity consumption. Here, the emission factors can vary a lot, depending on how the electricity is produced. For example, in the European Union, the average emission factor is about 0.233 kilograms of CO2 per kilowatt hour. For example, in the United States, it's higher. It's around 0.455 kilograms of CO2e per kilowatt hour, mostly due to fossil fuel use. In Norway, where electricity comes mainly from hydropower, the factor is extremely low. It's just 0.011 kilograms of CO2e per kilowatt hour. On the other hand, in China, which still relies heavily on coal, has a higher factor of 0.707 kilograms of CO2 per kilowatt hour. Now let's look at fuel combustion. Burning 1 liter of diesel releases around 2.68 kilograms of CO2e. Gasoline emits a bit less, about 2.31 kilograms of CO2e per liter. Natural gas is lower, with about 1.96 kilograms of CO2e per cubic meter, but coal has one of the highest factors, around 2.86 kilograms of CO2e per kilogram burned. So when it comes to transportation, the emission factors depends on a lot on the mode of travel. A passenger car running on gasoline emits about 0.192 kilograms of CO2e per kilometer. A diesel truck is even higher, with around 0.252 kilograms of CO2 per kilometer. For short haul flights, the factor is around 0.255 kilograms of CO2 per passenger kilometer. Rail travel, by contrast, is much more efficient, with only 0.041 kilograms of CO2 per passenger kilometer. And finally, let's look at waste management. We will talk about it in the next session. But landfilling municipal solid waste has an emission factor of about 1.39 kilograms of CO2e per kilogram of waste. Interestingly, recycling plastic can actually have a negative emission factor, about minus 0.82 kilograms of CO2e per hour. That means it can even count as a carbon credit, since it avoids emissions that would otherwise occur. These examples clearly shows that emission factors vary widely depending on both the type of activity and the regional context. That's why it is so important to choose the right factor, because using the wrong one can seriously distort the final carbon footprint calculation. So now that we understand what emission factors are and how they vary, let's look at how to actually apply them in carbon footprint calculations. Oh, sorry.
Sorry, you're not on this correct slide. Yeah, thank you.
Yeah, thank you very much. Yes, so the basic formula for calculating emissions is really simple. Emissions expressed in kilograms of CO2e are equal to the amount of activity multiplied by the emission factor. Let's quickly break that down. So activity data is the measurable part of what the organization does. This could be how much fuel is used, how much electricity is consumed, or how far vehicles travel, and so on. Emission factor tells us how much CO2e is released per unit of that activity. So for each liter of fuel, each kilowatt hour of electricity, or each kilometer traveled, the factor gives us the emissions. So let's look at a simple example how to make it clearer. Imagine a company uses 100,000 kilowatts hour of electricity in 1 year. Let's say the regional emission factor for electricity is 0.233 kilograms of CO2e per kilowatt hour. Now we apply the formula. 100,000 times 0.233 equals 23,300 kilograms of CO2 equivalent. And that's the total amount of emissions from electricity use. And when we convert it to tons, that's about 23.3 tons of CO2e. So this means that just from electricity use, the company is responsible for about 23.3 tons of CO2e emissions in that year. This kind of calculation is very useful because it allows companies to understand their impact, to track changes over time, and to develop strategies to reduce emissions in a focused, data-driven way. So yes, now let's talk about challenges and limitations of emission factors. So even though emission factors are incredibly useful tools, in carbon footprint calculation, they obviously do come with some challenges and limitations that we need to keep in mind. One of the biggest challenges is variability. Emissions factors can differ for a lot depending on location, technology, and even fuel quality. For example, the emission factor for electricity generated for coal is much higher than for electricity from hydropower. So using the wrong factor, say a global average instead of the local one, can seriously distort the results. Then there's the issue of accuracy. If we use outdated emission factors or ones that aren't specific to our region or industry, we might end up with misleading results. This means our carbon footprint might look accurate, but in reality, it might not reflect the true impact. And Scope 3 emissions present another big challenge because they come from indirect activities like supply chains or product use. It's often difficult to get detailed data. In these cases, we sometimes have to rely on composite emission factors or even assumptions, which can reduce the reliability of the results. And finally, there's the issue of lack of specificity. Generic emission factors don't always reflect the unique characteristics of a specific process of operation. Even if we're using technically correct factor, it might still not fully represent what's actually happening in our organization. So how can we deal with these challenges and still aim for accuracy? Here are a few best practices that can really help. First, always try to use the most recent emission factors available. As data improves, the energy system changes. These numbers are regularly updated. Second, choose emission factors that are region-specific and, if possible, industry-specific. This greatly improves accuracy. Third, where you can, try to cross-check the data from multiple sources. This can help validate your assumptions and catch any inconsistencies. And finally, invest in better monitoring and data collection wherever possible. The more precise your input data is, the more accurate your carbon footprint will be. So yes, emission factors do have limitations, but if we're aware of them and take the right steps to address them, we can still ensure that our carbon footprint calculations are as accurate, transparent, and reliable as possible. So let's wrap our section on emission factors with a few key takeaways. Understanding how emission factors work and how to apply them correctly is essential for making accurate carbon footprint calculation. By choosing reliable, up-to-date, and context-specific factors, organization can estimate their emissions with confidence and create targeted strategies to reduce them. And now that we have solid understanding of emission factors, we are ready to move on to the next step, which is calculating emissions from specific scopes. I'm sorry for that. So let's start with Scope 1, direct emissions. Scope 1 emissions refer to direct greenhouse gas emissions from sources that are owned or controlled by organization. These emissions typically result from combustion or chemical processes that release GHGs directly into the atmosphere. These are four main categories of Scope 1 emissions. First one is stationary combustion. This includes emissions from burning fuels on site, like natural gas, diesel, or coal for heat energy or industrial use. For example, if a manufacturing facility uses a natural gas boiler for heating, the combustion process will release CO2 into the atmosphere. Mobile combustion, these are emissions from company-owned vehicles or mobile machinery that run on gasoline, diesel, or other fuels. Think of a logistics company with a fleet of delivery trucks. Every kilometer driven produces CO2 and potentially other gases like nitrogen oxides. And fugitive emissions, these are unintentional leaks of greenhouse gases, often from equipment like refrigerator or air conditioning systems, or from industrial gas flaring. So, for example, supermarkets and warehouses might experience refrigerant leaks from cooling system, which release gases like methane into the atmosphere. And process emissions, these come from chemical reactions in industrial processes that release greenhouse gas as byproducts. A good example is cement production, where CO2 is released during the breakdown of calcium carbonate. So understanding these categories help organizations identify which activities fall under Scope 1 and how to start measuring them accurately. So I hope that this also answers the previous question, why we have equivalents, why we must take into the consideration every organization for itself. And now we were at Scope 1 emissions, and let's go further. So even though Scope 1 emissions are considered direct, measuring them accurately can still be quite challenging. And there are a few reasons why. The first, fuel types, like we mentioned, vary and also do their combustion properties. Different types of fuel burn differently, and the efficiency of combustion can vary depending on the equipment used, how well it's maintained, and how it's operated. So even if you know how much fuel was used, the actual emissions can differ from the one situation to another. Another big challenge comes from fugitive emissions. These are unintended leaks, often from the refrigerator systems or industrial equipment. If the systems for monitoring leaks aren't properly maintained, these emissions can go completely undetected. So, what can organizations do to improve the accuracy of their direct emissions data? Here are some best practices. First, implement a continuous monitoring system. Automated sensors can detect and measure emissions in real time. This helps catch problems early on and reduces the risk of missing important data. Then second, conduct regular maintenance, keeping equipment in good working condition and checking regularly for leaks helps both with data quality and with actually reducing unnecessary emissions. And third, use standardized emission factors from reputable sources, which is such as IPCC or national environmental agencies. This ensures that the calculations are consistent and in line with best practices. And finally, make sure to verify and audit the data regularly. Having an independent third-party review the data adds an extra layer of credibility and transparency, especially if the information is being used in public reporting or sustainability disclosures. But like we said on the previous session, for many companies, it's becoming mandatory, not voluntary anymore. So by applying these best practices, companies can ensure that their Scope 1 emissions data is not only accurate, but also trusted by both internal and external stakeholders. Now let's look at the quick example to see how we calculate direct emissions under Scope 1. So imagine a manufacturing plant that uses 50,000 liters of diesel per year to operate its boilers. I'm sorry. We know that the emission factor for diesel is 2.68 kilograms of CO2 equivalent per liter. So we apply the basic formula. Emissions equal activity data multiplied by the emission factor. So in this case, 50,000 liters times 2.68 kilograms of CO2e per liter equals 134,000 kilograms of CO2 equivalent. That equals 134 tons of CO2 equivalent per year. And this calculation shows how different emissions from fuel combustion can be quantified in a clear and consistent way. And now let's look at some effective mitigation strategies for reducing direct emissions or Scope 1. We know that reducing these emissions can be challenging because they're tied directly to on-site activities, fuel use, and equipment. But with the right strategies, it's possible to make a substantial impact. And here are a few key approaches. First, switching to clearer fuels. By moving from coal or diesel to natural gas or renewable biofuels, organizations can significantly lower their CO2 emissions. For example, a public transport company might replace its diesel buses with electronic or hydrogen-powered vehicles, reducing both emissions and noise pollution. Then second, implementing energy efficiency measures. Optimizing how energy is used, especially in combustion process, can make a big difference. This includes things like regular maintenance of boilers, adjusting combustion parameters, and upgrading outdated equipment. Third, capturing fugitive emissions. Leaks from refrigerator systems or industrial equipment can go unnoticed, like we said, but they often involve gases with high global warming potential. So installing advanced leak detection systems and switching to low GWP refrigerants can help prevent these emissions. A good example would be food retailers upgrading their refrigerator systems to reduce leaks of HFCs. And fourth, adapting renewable energy solution. Generating energy on site from solar or wind can reduce reliance on fossil fuels altogether. And for instance, manufacturing facilities can install solar panels or rooftops and use that electricity to power parts of their operations. So this all means that we need a certain amount of budget, and that's why it's so important that ESG sustainability is not something just ad hoc. It is really must become a strategy of organizations. So let's look at a real-world example of how this works in practice. I took a study case example of Siemens. Siemens is a global industrial technology company that has taken significant steps to reduce its Scope 1 emissions. They've implemented a comprehensive energy management system across their production sites, focusing on three key areas. The first one is fuel switching, replacing all fired boilers with natural gas and biomass alternatives. Then energy optimization, using advanced monitoring systems to detect inefficiencies and reduce unnecessary fuel use, and on-site renewable energy, installing solar power plants and wind turbines to generate electricity for their operations. So as a result, Siemens has not only reduced its direct emissions, but also achieved cost savings. Their proactive approach is a great example of how industrial companies can address emissions while also improving their bottom line. Now let's move on to Scope 2 emissions, which represent another important part of organization carbon footprint. Scope 2 refers to indirect greenhouse gas emissions that come from consumption of purchased energy, mainly electricity, steam, heating, and cooling. Even though these emissions don't occur on site, they are still directly linked to the organization's energy use. That's why they're included in the carbon footprint, because without the organization's demand, these emissions wouldn't exist. So Scope 2 emissions are especially important in sectors with high electricity consumption, such as manufacturing, retail, or data centers. Unlike Scope 1 emissions, which happen from direct fuel use of or the industrial process on site, Scope 2 emissions occur off-site, typically at power plants or district heating facilities, but they are still the result of the organization's operation. So the main sources of Scope 2 emissions are, first, purchased electricity. This is the most common use of Scope 2 emissions, and it is usually generated by burning fossil fuels like coal, natural gas, or oil to produce electricity that's then delivered to the organization via the power grid. For example, an office building using electricity from the grid for lighting, heating, and cooling creates Scope 2 emissions through its electricity use. Second, purchase steam and heating. These emissions come from centralized heating systems where fuels are burned at another facility and the heat is then distributed to the organization. Think of industrial sites using district heating powered by natural gas or coal. And third, purchased cooling. Cooling is often purchased through centralized cooling plants that use electricity to operate. For example, large commercial buildings connected to district cooling system will indirectly generate emissions from the electricity used to run those systems. So why does Scope 2 matter? Well, in many companies, Scope 2 is second largest source of emissions right after Scope 3. It reflects the company's dependence on external energy sources, which are often based on fossil fuels. By reducing Scope 2 emissions, organizations can not only lower their carbon footprint, but also reduce energy costs and improve energy security. So companies that actively manage Scope 2 emissions show that they're serious about sustainability and often brings a competitive advantage, especially in markets where environmental performance matters. Let's now go through how to calculate Scope 2 emissions. The process is actually quite straightforward, like in Scope 1, once you understand the basic steps. There are three main steps involved. Step 1 is data collection. We start by gathering key information about the organization's energy use. Most often that includes energy consumption, measured in kilowatts hours, that is usually taken from utility bills. Then heating and cooling consumption, which is sometimes measured in megajoules or gigajoules, depending on the system. These values are often tracked through internal energy management system. And of course, we also need the emission factors, which tell us how much CO2 equivalent is produced by per unit of energy consumed. So emission factors can vary a lot, like we said, depending on the type of energy used and the region where it comes from. This is so very important, and we have to really be careful when calculating. So we typically get these values from national databases or international sources such as IPCC, or sometimes directly from energy suppliers if they provide region-specific data. Then step 2 is selecting the appropriate emission factor. This step is also really important because it directly affects how accurate our calculation will be. So emission factors can vary based on the type of energy, for example, coal, natural gas, wind, hydropower, solar, or nuclear, the region, because every country or even sub-region may have a different energy mix. And the grid-specific data, especially for electricity, since some grids rely more heavily on fossil fuels than others. And just to give you a sense of the range, so electricity generated from coal might have an emission factor around 0.9 kilograms of CO2 equivalent per kilowatt hour. From natural gas is lower, about 0.4 kilograms per kilowatt hour. And from renewable sources like wind or solar, the emission factor is usually 0 or close to 0. Step 3 is the calculation itself. Once we have the consumption data and the emission factor, we use a very simple formula: emissions equal energy consumption multiplied by the emission factor. So, for example, if a company consumes 100,000 kilowatt hours of electricity and the emission factor is 0.233 kilograms of CO2e per hour, then 100,000 kilowatt hours multiplied by 0.233 kilograms of CO2 equivalent per kilowatt hour equals 23,300 kilograms of CO2e, or 23.3 tons of CO2e. This gives us the total Scope 2 emissions linked to that energy use. Okay, so let's look at a simple example to better understand how Scope 2 emissions are calculated in practice. Imagine a retail company that operates a chain of 10 stores. Each store consumes an average of 120,000 kilowatt hours of electricity per year. The emission factor for electricity in their region is 0.45 kilograms of CO2e per kilowatt hour. So to calculate the emissions for one store, we multiply the electricity used by the emission factor. So 120,000 kilowatt hours times 0.45 equals 54,000 kilograms of CO2e. That's 54 tons of CO2e per year from a single store. Since a company operates 10 stores, we multiply that amount by 10. 54,000 times 10 equals 540,000 kilograms of CO2e, or 540 tons of CO2 equivalent per year for the entire retail chain. By calculating emissions this way, the company gets a clear and measurable picture of its total carbon footprint from electricity use. And this helps them develop more targeted and effective strategies to reduce their emissions in the future. So let's now look at how organization can reduce Scope 2 emissions. Strategic approach to emission reduction. Reducing emissions efficiently requires a focus on both sourcing renewable energy and enhancing energy efficiency. So renewable energy procurement. One key strategy is purchasing renewable energy companies can either buy green electricity directly or use certificates like renewable energy certificates or guarantees of origin, depending on regional availability. For example, Google achieves carbon neutrality in its operations by purchasing renewable energy for its data centers. On-site renewable energy generation, another effective method is generating renewable energy on-site using solar panels or wind turbines. Gasless gigafactories, for example, utilize solar roof to power their production processes and reduce grid dependence. And then energy efficiency. Efficiency improvements are also crucial. Steps include switching to LED lighting, upgrading to high efficiency HVAC systems, and implementing smart building automation technologies. Walmart, for example, because it is a global chain, transitioned to LED lighting, not only reduced emissions, but also lowered their energy costs. Monitoring and management. Regular energy audits are vital for identifying inefficiencies and guiding better energy management. Adopting standards like ISO 50001 can enhance energy management and promote continuous improvement. And by integrating renewable energy sourcing with effective energy management, companies can significantly cut their Scope 2 emissions and achieve cost savings. Let's take a look at a real-world example on how Scope 2 emissions can be significantly reduced, and this time from Apple. So Apple has made remarkable progress in lowering its Scope 2 emissions by combining renewable energy sourcing with energy efficiency improvements. The company has reached 100% renewable energy use across all of its global facilities, including retail, stores, offices, and data centers. So how did they do it? First, Apple secured long-term contracts to purchase renewable energy directly from energy producers. These are called power purchase agreements or PPAs, and they ensure that Apple's energy needs are covered with clean electricity while also significantly reducing their carbon footprint. Next, they invested in on-site solar installations that includes building solar farms and installing rooftop solar panels at their offices and production sites so they can generate clean energy exactly where it's needed. But Apple didn't stop with their own operations. They also turned their attention to their supply chain. They've actively encouraged suppliers to switch to renewable energy, making sustainability not just Apple's responsibility, but a shared goal across their value chain. And finally, Apple focused on energy efficiency. They upgraded their facilities by retrofitting LED lighting, installing high-efficiency HVAC systems, and optimizing building operations to cut down on energy use even further. So by taking this comprehensive approach, Apple has proven that even a large global corporation can make major reductions in Scope 2 emissions. So their commitment to renewable energy and efficient operations does not only reduce their carbon footprint, it also strengthens their position as a global leader in environmental stewardship. And now let's turn to Scope 3 emissions, which are by far the most complex and challenging to calculate. So Scope 3 includes a wide range of indirect emissions that happen throughout the entire value chain, both upstream and downstream of the organization's operation. These are emissions that comes from activities the company doesn't own or directly control, but that are still connected to its business. So things like the production of raw materials, transportation by third parties, employee commuting, business travel, product use, and end-of-life disposal. So for many companies, Scope 3 emissions represent the largest part of their total carbon footprint, basically, especially in industries like retail, manufacturing, or food production, where supply chains are complex and global. Even though their indirect Scope 3 emissions are crucial for understanding the full environmental impact of an organization and for designing meaningful carbon reduction strategies. So why are Scope 3 emissions so important? Well, first, because of their magnitude. In many organizations, Scope 3 emissions make up the majority of total emissions. Take the retail sector, for example, emissions from raw material extraction, transportation, and product disposal can far exceed those from direct operations. Second, stakeholder expectations. Today, investors and customers and regulators increasingly expect companies to report on and actively reduce Scope 3 emissions because they reflect the broader impact of companies' activities. Third, supply chain transparency. Measuring Scope 3 emissions helps companies identify emissions hotspots in their supply chain and work together with suppliers to reduce them. This leads to smarter procurement decisions and better collaboration across the value chain. And fourth, brand reputation and accountability. So companies that tackle Scope 3 emissions show a genuine commitment to sustainability. This can enhance the reputation, strengthen stakeholders' trust, and improve long-term business resilience. So let's take a look at the 15 categories of Scope 3 emissions as defined by Greenhouse Gas Protocol. The categories are grouped into two main areas. The first one is upstream emissions, which happen before the organization's operations, and downstream emissions, which occur after the product or service levels leaves the organizations. So starting with upstream emissions, like we said, these are emissions linked to activities that take place before the company takes ownership or control of product or service. So first category, purchased goods and services. These are emissions that come from producing the goods and services the company purchases, for example, emissions from raw material extractions and processing. Category 2, capital goods. These are emissions from producing long-term assets like machinery or buildings. For instance, CO2 emitted during the production of industrial equipment. Category 3, fuel and energy-related activities. This includes emissions from the fuel production, transport, and processing that are not already counted under Scope 1 or 2. For example, emissions from extracting and refining fuels used by the organization. Scope 4, upstream transportation and distribution. These are emissions from moving goods before they reach the organization, such as shipping raw materials from suppliers. Category 5, waste generated in operations. This includes emissions from managing waste created during business operations, such as landfill or recycling. For example, methane emissions from landfilling industrial waste. Category 6, business travel. These are emissions from employees traveling for work purposes by train, air, or car. For example, emissions from a flight to attend a business meeting. In our case, in Telemax Slovenia or United Group, we use the ICAO carbon emissions calculator for air travel. This tool calculates CO2 emissions based on flight distance, aircraft type, and seating class, which helps ensure consistency and accuracy in reporting. So then we have two more categories. Category 7, employee commuting. These emissions comes from the daily travel of employees between home and work. For example, emissions from cars, buses, or trains used to commute. And category 8, upstream leased assets. These are emissions from leased assets that the organization uses but does not own, and which are not already included in scope 1 or 2, for example, emissions from rented office spaces. So now let's move on to downstream emissions. These are emissions that occur after the product or service leaves the organization. Category 9, downstream transportation and distribution. These include emissions from delivering products to customers or retail outlets. For example, emissions from trucks or distribution services. Then category 10, processing of sold products. These emissions occur when the products sold by the organization are further processed by third parties, for example, raw materials that are later refined or transformed. Then we have category 11, use of sold products. These are emissions generated when customers use the product, for instance, emissions from using a gas-powered appliance. Category 12, end-of-life treatment of sold products. This includes emissions from how products are disposed of, whether through landfilling or in ceration or recycling. For example, methane emissions from landfilling, product packaging. Category 13, downstream leased assets. These are emissions from assets the organization owns, but leases out to other entities, for example, machinery rented out to a third party. And hang on, just two more categories. Category 14, franchises. These are emissions from franchise operations that operate under the company's brand, but are not directly owned or controlled by the reporting organization. For example, a franchise store using the company's name and model. And the last one, category 15, investments. These include emissions that come from financial investments, such as shares or portfolios in other companies. For instance, emissions from companies in which the organization holds an ownership stake. So, understanding all 15 categories allows organization to build a complete picture of their Scope 3 footprint and identify where the biggest opportunities for reduction might be. But calculating Scope 3 emissions can be complex, like we've seen, because of the wide range of sources involved, but the process follows 4 clear steps. First one, step 1 is to identify the relevant categories. Luckily, not all of these 15 Scope 3 categories will apply to every organization. The first step is to analyze your business activities and supply chain to identify which categories are most relevant and likely to represent the largest share of emissions. Step 2 is data collection. Collecting accurate data for Scope 3 can be challenging because much of it comes from outside your organization. There are few useful strategies for gathering this data. First, engage with your suppliers. work with them to collect data about their emissions, especially for purchased goods and materials. Second, use estimations or proxies when direct data isn't available. In these cases, industry averages or published databases can be helpful. And third, consider using third-party tools or platforms that can help aggregate and estimate emissions across complex supply chains. Step 3 is to apply the appropriate emission factors. These need to match the type of activity or material you're analyzing. For example, for purchased goods and services, use emission factors based on the material type, such as steel, plastic, or textile. For business travel, use emissions factor that reflect the mode of travel, air, train, or car, and the distance traveled. And for waste disposal, use landfill or recycling emissions factors that are specific to the type of waste. Step 4 is the calculation. The basic formula is, again, simple. Formula is always simple, but how to get to data, that's more difficult. So the formula is emission equal activity data multiplied by the emission factor. In other words, emissions in kilograms of CO2e equals activity data times emission factor. Let's look at a quick example. Imagine an employee travels 10,000 kilometers by plane on short-haul flights. The emission factor for this type of air travel is 0.255 kilograms of CO2 equivalent per kilometer. So we calculate 10,000 kilometers multiplied by 0.25 equals 2,550 kilograms of CO2e. So that's the total emission from that one trip. So while Scope 3 emissions can be complex and challenging to measure, following a structured approach, identifying relevant categories, collecting the best available data, applying the right emission factors, and calculating carefully makes it possible to understand and manage even the most indirect parts of a company's carbon footprint. And these insights give organization the foundation they need to develop meaningful reduction strategies, not just within their own operations, but across the entire value chain. Now that we've covered how Scope 3 emissions are calculated, let's move on to reducing Scope 3 emissions. Even though these emissions are indirect and often outside the company's direct control, there are still several practical and impactful strategies that organizations can adopt. First, supply chain collaboration. One of the most effective ways to reduce Scope 3 emissions is by working closely with suppliers. By engaging them, companies can both collect better emissions data and encourage suppliers to reduce their own carbon footprints. For example, again, Walmart runs an initiative called Project Gigaton, where they partner with suppliers to reduce emissions across the entire supply chain. This approach not only improves data transparency, but also builds a culture of shared responsibility. Second, product design and life cycle optimization. Organizations can reduce emissions by rethinking how products are designed, from the materials used to the way products are produced, used, or disposed of. A good example is Unilever, which has redesigned much of its packaging to be lighter and to include more recycled materials. These small changes at the design stage can lead to significant emissions reduction over the full life cycle of the product. Third, sustainable transport and logistics. Transportation is a major part of Scope 3 emissions, especially in global supply chain. Companies can reduce these emissions by optimizing routes, using more efficient transport methods, and switching to low-emission vehicles. For instance, DHL has introduced electric delivery vehicles and improved their logistic network planning to reduce emissions from transportation, obviously where there is possibility based on the infrastructure. And fourth, educating consumers. So emissions during the use phase of products can also be significant, especially for energy-using goods. By helping customers use products more efficiently, companies can reduce downstream emissions. A good example of the development of energy-efficient home appliances, which consume less electricity and reduce emissions over time. So companies can also provide instructions or tools that help users lower their energy use in practice. Now let's look at concrete example mentioned before on how a large company is addressing Scope 3 emissions across its value chain. Walmart launched an initiative called Project Gigaton with the goal of reducing 1 billion metric tons or 1 gigaton of greenhouse gas emissions from its global value chain by the year of 2030. This project is based on a few key areas. First, supplier engagement. Walmart encourages its suppliers to set their own emissions reduction targets and to report on their progress. So this creates a ripple effect, empowering thousands of companies to take climate action. Second, sustainable agriculture. The initiative promotes use of regenerative farming practices, which not only reduce emissions, but also improve soil health and biodiversity. And third, low carbon products. Walmart works to expand the development and sale of products with lower carbon footprints, whether through better materials, production methods, or packaging. So by collaborating with suppliers and giving them tools and support to reduce their emissions, Walmart is addressing one of the most significant and most difficult parts of its Scope 3 footprint. So Project Gigaton is a good example of how shared responsibility and large-scale collaboration can drive meaningful change across the entire value chain. Now let's take a look at some practical tips for collecting data when calculating a carbon footprint altogether. So, as we know, accurate data collection is the foundation of any reliable carbon footprint calculation. Without the right data, the final results can be misleading or incomplete, and then that can lead to the wrong decisions. Organizations often face challenges when gathering emissions data, especially for indirect emissions under Scope 2 and Scope 3. So what can we make, how can we make the data collection process easier and more effective? So first, identify data sources early. Start by mapping out where our emissions-related data is coming from across the organization. This is a very important step. And this must include utility bills, especially for electricity, heating, and cooling. This is important for Scope 2. Then travel records, such as flight bookings or car rental logs for Scope 3 business travel, and fuel consumption records from companies, vehicles, or on-site machinery. This is the Scope 1 data. And supply chain data, which involves engaging with suppliers to understand emissions linked to raw materials and services. Second, implement proper data collection system. Manual data tracking can lead to errors, so it's important to use systems or tools that help collect and manage data consistently. Just a moment, please. Okay, so some useful tools include energy management software for tracking electricity, heating, and water consumption across buildings, carbon accounting platforms like CIMAPRO or EcoReal, which help organize the data and automatically apply the correct emission factors, and fleet management tools for tracking vehicle usage, fuel consumption, and emissions from company transport. Third, collaborate with suppliers and partners. This is a difficult one, but this is especially important for Scope 3 emissions, where you don't often get or have direct access to the data. So there are few effective ways to do this. First one is send out questionnaires or surveys asking suppliers to report on emissions from production, transportation, or product disposal. Use industry reports when direct supplier data isn't available. These often include average emission figures you can use as a proxy. In some cases, hire third-party auditors to help gather and validate data from complex or critical supply chain stages. Fourth, use proxies when data is missing. There will be times when exact data just isn't available, especially from Scope 3. In those cases, you can use estimates or industry averages. For example, if you are missing energy data, you can use regional or national averages for electricity or heating. For transportation-related emissions in the supply chain, you can estimate based on typical distance or modes of transport used. Fifth, maintain a constant reporting period. To make your data comparable and track progress over time, always use the same reporting period. Typically is 1 year. Because also, like said before, for many companies is mandatory. So this is usually aligned with the company's fiscal year or sustainability reporting cycle. And finally, review and validate the data. Before finalizing the carbon footprint calculation, go back and double check the numbers. Here's how. Cross-check data sources across departments, like comparing energy data from facilities with finance and procurement records. Be careful that there's no double counting. And if you're planning to publish your results or include them in formal reports, consider external verification. Having a third party review your data adds credibility and trust, especially when communicating with stakeholders. As we move on, we'll explore where to find reliable, reliable emission factors, which we talked about, crucial for accurate carbon footprint calculations. Emission factors convert direct activity data like energy use or kilometers traveled into CO2 equivalents. Their currency directly influences our results, so they are very important. First, for Slovenia and Austria, the most relevant sources for standardized emissions factors include European Environmental Agency, EEA, which provides harmonized emissions factors used across EU member states. Then Intergovernmental Panel on Climate Change offers internationally recognized default values, especially useful when no national data is available. For Slovenia, Environmental Agency of the Republic of Slovenia publishes national greenhouse gas inventories and country-specific emissions factors. And Austria has Federal Environment Agency, which provides emission factors tailored to Austria's specific energy mix and economic activities. Then we have also national energy and statistical agencies, which offers activity data which, combined with emission factors, enable accurate carbon footprint calculations, and national and EU legislations, which also refer to standardized emission factors, especially for regulatory and reporting purposes. Second, there are industry-specific databases which offer more accurate emission factors for particular sectors. Examples include the International Energy Agency and national databases such as UBA Austria or ARSO Slovenia, which provide sector-specific data for energy, transport, and industry. Third, academic and research institutions, including universities and EU research bodies like the Joint Research Centre, published emission factors for specific technologies, products, or regions, especially available for Scope 3 analysis. Then we have carbon accounting software. Comes with built-in, regularly updated emission factors libraries, helping matching activities to the correct factors and reduce calculation errors. Then fifth, for Scope 3 emission, especially collaborating with third-party data providers such as CDP or Carbon Trust, and encouraging local supplier data ensures more complete and verified reporting. And sixth, online calculators, including tools from UBA Austria or European Environmental Agency, offer accessible pre-filled emission factors for common activities. So accurate and up-to-date emission factors are essential for meaningful GHG accounting. With the right sources and tools, organizations can calculate, report, and reduce emissions across all scopes with confidence. So we've already discussed ELC earlier, but let's now see how this method is applied in calculating a product's carbon footprint. ELC, like we said, is a systematic approach for assessing the environmental impacts across all stages of a product life, starting from raw material extraction all the way to disposal. By using ELC, companies can truly understand the full carbon impact of their products and find opportunities to reduce emissions at each stage. Why is ELC so crucial for product carbon footprinting? First, it takes a holistic approach. ELC doesn't just focus on one part of the product life. It looks at every environmental impact across the entire cycle, giving the complete view of the product's carbon footprint. Then second, it includes comprehensive data. ELC captures emissions from production, transportation, use, and even end-of-life disposal of the product. And third, it provides accountable insights. So ELC helps companies pinpoint which stages of life cycle are responsible for the most carbon emissions. This allows businesses to focus their efforts on the areas that will have the biggest impact. So key stages of products life cycle in LAC. Raw material extraction. This includes emissions from activities like mining, agriculture, and forestry. For example, the carbon footprint of cotton farming or mining from metals used in electronics. Then manufacturing, emissions during the production process. This covers everything from energy consumption in factories to waste generation. Then transportation, emissions generated during the logistics of transporting raw materials, components, and the final product of consumers or retailers. Use, emissions that happen when the product is used by the consumer. This includes things like electricity consumption for home appliances or fuel consumption for vehicles, and end of life. Finally, emissions from the disposal, recycling, or incineration of the product once it reaches the end of its life cycle. So by considering all these stages, LCA provides a complete and accurate picture of the environmental impact of the product. So with all that said, let's review the key steps involving in calculating a product carbon footprint with the life cycle assessment methodology, which help us understand the full carbon impact of a product. Step 1. First is, we said, define the goal and scope. Establish clear goals for assessment, such as improving design, reducing emissions, or compliance with regulations. Then define the study's scope, including which life cycle stages to consider, from raw material extraction to disposal, cradle to grave, or just up to production, cradle to gate. It's crucial to specify whether to include just the product or also packaging, transport, and disposal to prevent scope creep. Step 2, data collection. Gather data on materials used, energy consumption, transportation, and waste and emissions. Engaging suppliers early can help obtain accurate raw materials and manufacturing data, crucial for precise calculation. Step 3, apply emission factors. With the collected data, apply emission factors to convert activities like energy use or transportation into CO2e. These factors found through the sources which we mentioned, EPA, DEFRA, or tools like CIMAPRO and GABI help estimate greenhouse gas emissions across different activities. And by systematically following these steps, we can calculate the carbon footprint of a product accurately, aiding in between environmental management and strategy formulation. Then we have step 4, which is calculate emissions. Obviously, now that you have the data and the emission factors, it's time to calculate emissions for each stage of the product life cycle. So the formula is simple again. Emissions equals activity data times emission factors. So let's go through a couple of examples. First of all, transportation emissions. If a product travels 1,000 kilometers by truck and the emission factors for truck transportation is 0.15 kilogram CO2e per kilometer per ton, the emissions from transport would be 1,000 kilometers times 0.15 kilometer CO2e per kilometer per ton, which equals 150 kilograms CO2e. Then we have manufacturing emissions. If the product requires 10 kilowatt hours of electricity to be manufactured, and the regional emission factor is 0.233 kilograms CO2e per kilometer per ton, the emission from manufacturing would be 10 kilowatt hours times 0.233 kilograms CO2 equivalent per kilo per ton equals 233 kilo CO2e. Step 5 is interpretation and analysis. Once you've calculated the emissions for all stages of the product's life cycle, the next step is to analyze the results. First is identify hotspots, which stages of product's life contribute to the most of its carbon footprint. These are the areas to focus on for improvement, and compare alternatives. If possible, compare the carbon footprints of different products of materials to see where lower carbon alternatives can be used. So to summarize, following these steps allows you to accurately calculate and understand the carbon footprint of a product, identify areas for reduction, and make more sustainable decisions in the future. And now we are at the last part of our today's session, and we will look at how measuring carbon footprint drives business success and achieves strategic goals. So when companies start measuring their carbon footprint, the focus often shifts to environmental impacts. However, the data from carbon footprint calculations go far beyond its environmental concerns. It directly influences key business strategies and long-term planning. So in this section, we will explore how a company's efforts to measure and reduce its carbon footprint can be a driving force for achieving broader business goals, particularly cost reduction. One of the key reasons why companies focus on measuring their carbon footprint is to basically reduce costs, because many companies don't realize that reducing carbon emissions can lead directly to cost savings. For example, energy efficiency. By monitoring and reducing energy consumption, companies can lower their utility bills, and swapping to energy efficient equipment or high efficiency machinery reduces both emissions and energy costs, or electricity and gas. Then we have waste reduction. Reducing waste, whether it's excess packaging, unused materials, or manufacturing defects, helps companies save on disposal fees and material costs. So additionally, encouraging use and recycling lowers operational expenses. And transportation optimization. For companies with large supply chains, transportation costs are significant. So by optimizing delivery routes, switching to energy efficient vehicles, or reducing the number of trips, companies can significantly lower the fuel consumption, which directly reduces transportation costs. So in conclusion, a company's carbon footprint is closely connected to how it manages resources, cuts inefficiencies, and saves money over time, basically. But in today's marketplace, consumers are being increasingly aware of environmental issues, and many now prefer to support companies that demonstrate a genuine commitment to sustainability. So growing awareness and market differentiation. Environmental performance is increasingly becoming a key market differentiator for companies, because it's not just about price or product quality anymore. Consumers are also evaluating on how companies manage and reduce their carbon footprint. Then we have brand loyalty. Reducing your carbon footprint can significantly enhance brand loyalty. Market advantages. Sustainability is now competitive edge in business. Said many times today and on the lecture before, companies that demonstrate active efforts in reducing emissions are favored by consumers looking for products with smaller environmental impacts, including waste. So leaders in sustainability often experience increased sales as small consumers make purchasing decisions that prioritize environmental performance. So in conclusion, a robust commitment to reducing carbon emissions positions a company as a sustainability leader, opening up new market opportunities and building trust with environmental conscious consumers. Let's see how carbon footprint measurement helps with compliance. So as global regulation on carbon emissions tightened, organizations are increasingly compelled to comply to avoid significant risks such as fines, legal issues, and reputational damage. Proactive measurement and reporting of carbon emissions place companies in a stronger position to make these regulatory demands. So first is emission reduction targets. As we know, we have a strict carbon reduction targets with expectation of increased severity over time. So monitoring emissions allows companies to plan ahead for these changes. And carbon trading and taxation. Regions implementing carbon pricing mechanisms such as carbon taxes or cap and trade systems mean businesses face financial penalties unless they reduce their carbon output. So in conclusion, actively managing and reducing carbon emissions is crucial not just for environmental protection, but also from mitigation risks, complying with regulators, avoiding penalties, and achieving financial savings. Managing carbon emissions extends beyond regulatory compliance and cost savings. It is a crucial part of companies' corporate sustainability, social responsibility. So as consumers, investors, and employees increasingly demand environmental accountability, companies that actively measure, report, and reduce their carbon emissions show their commitment to environmental stewardship. So prioritizing carbon management can attract top talent, especially among millennials and Gen Z who value sustainability and are poised to dominate the workforce. Companies recognized for environmental efforts are more attractive to these younger generations who prefer to work for companies with that align with their ecological values. So by integrating effective carbon footprint management into their operation, companies not only adhere to ESG principles, but also enhance their social credibility and brand reputation on a competitive market. So the big question is how to integrate carbon footprint into sustainability and ESG strategies. So this is crucial for achieving long-term environmental goals. Companies that make carbon management part of their core strategy often experience both financial and reputational benefits. And this is how you can approach it. First, we said you have to establish clear targets. So define specific carbon reduction goals aligned with global initiatives like Paris Agreement. These targets should connect directly to the company's broader environmental objectives. Then link to business objectives, very important. So ensure carbon reduction initiatives support the company's business goals, enhancing operational efficiency or sustainability product lines. Ensure top-down support. So successful carbon reduction strategies require strong leadership support, which includes prioritizing sustainability, allocating sources, and driving initiatives across departments. Transparency in reporting is also very important. Accurate and reliable reporting of carbon emissions is critical and crucial. This includes annual sustainability reports, which we talked about, third-party verification, and carbon disclosure project. Stakeholder engagement, supplier collaboration. We said collaborate with suppliers to reduce Scope 3 emissions by encouraging sustainable practices, and customer education. Inform customers about the carbon footprint of products through the labels, online platforms, and marketing materials. So integrating carbon footprint measurement into ESG strategies not only promotes transparency, but also builds trust with stakeholders, ensuring sustainability is a core aspect of business model. So improving sustainability is essential in product development and innovation, and calculating a product's carbon footprint offers insights that aid companies in identifying improvement areas and design more sustainable products. And understanding a product's carbon footprint helps manufacturers make informed choices about materials, favoring those with lower footprints or recycled options, significantly minimizing production environmental impact. Energy efficiency is also crucial, so employing energy-saving features and efficient manufacturing process reduces emissions across a product life cycle. Adopting circular economy principles designed for product longevity, repairability, and recyclability helps reduce the carbon footprint over time. Ensuring products are durable and generate less waste and emissions at life's end. And beyond product design, companies must reduce emissions across their supply chain. Collaborating with suppliers who adopt renewable energy or sustainable practices in farming and forestry can further diminish a product's carbon footprint. In sum, a product's carbon footprint is a key sustainability indicator. Integrating carbon footprint measurement into business strategies not only aids environmental protection, but also brings business advantages such as cost saving, enhanced brand reputation, and regulatory compliance. As business evolve, embedding carbon footprint management into sustainability strategies is crucial for long-term success and maintaining a market competitive edge. So integrating carbon footprint measurement into sustainability and ESG strategies is essential for businesses' success and regulatory compliance. So continuously measuring and managing carbon footprint is crucial, not just one-time effort. Businesses need to set clear, realistic carbon reduction targets aligned with global climate goals like the Paris Agreement. These targets should be part of broader sustainability objectives with regular monitoring and reporting through mechanisms like annual sustainability reports that include emissions data, progress and goals using standards like GRI or Global Reporting Initiative. Additionally, reducing carbon footprints should be integrated into product design to minimize emissions throughout their life cycle. For ESG reporting, disclosing carbon emission through platforms like Carbon Disclosure Project and having data verified by independent third parties enhances credibility and attracts investors. And effectively integrating carbon footprint measurement into broader ESG strategy not only ensures company, but also builds a strong, sustainable brand that secures long-term success. So the carbon footprint, the carbon footprint of a product is becoming an important factor in shaping consumers' behavior. More and more consumers are considering sustainability when making purchasing decisions and actively looking for products that reflect their environmental values. So companies can respond to this trend by providing clear and transparent carbon footprint information, helping consumers make informed, eco-conscious choices. One of most effective ways is through the use of certification and labels that show a product environmental impact and the company's broader sustainability efforts. For example, companies like Patagonia displays the B Corp certification, which reflects high standards of environmental and social responsibility. This builds consumers' trust and shows that the company is serious about ethical business practices. Another strong signal to sustainability-minded consumer is fair trade certification, which not only ensures that labor conditions but also promotes environmentally responsible farming methods. In addition of using certification, business can take proactive steps to raise awareness about the carbon footprint of their products and services. One way companies can increase awareness is through transparency and education, providing clear and sustainable information about the carbon footprint of products, through various communications channels is key. For instance, companies can use product packaging, websites, or social media to share carbon footprint information. So what about the future? The future of carbon footprint management is being shaped by significant advancements in technology. As businesses continue to strive towards reducing their emissions, new technologies are emerging that will help to monitor, track, and ultimately lower carbon emissions across various industries. These innovations are not only making carbon footprint calculation more accurate, but they are also enabling large-scale reduction in emissions. Looking specifically at high-emission industries such as cement, steel production, and chemicals, we can see that they are now exploring new technologies aimed at significantly reducing emissions. And these innovations are truly game changers in the quest for low carbon future. In the modern business landscape, big data and advanced digital tools are playing an increasingly important role in how companies track and reduce their carbon footprints. These technologies enable real-time monitoring, predictive analytics, and precise tracking of emissions, helping businesses identify hotspots and optimize operation. Emerging technology such as blockchain are also being explored, especially in pilot projects and research initiatives across Europe. While Project Chain can provide transparent and immutable records of emission data, the global companies like IBM are testing its potential to enhance supply chain transparency and data accuracy. Then artificial intelligence is another powerful tool, revolutionizing how companies manage their environmental impact. AI optimize production processes, predicts emission trends, and reduces resource consumption. For example, Google has implemented artificial intelligence to improve energy efficiency within its data centers by optimizing server cooling processes, thus reducing energy use and associated emissions. So similarly, Siemens applies AI in its industrial automation system to help manufacturers streamline production and cut down on energy consumption and emissions. Furthermore, the Internet of Things facilitates real-time emissions monitoring by connecting device and machines to the Internet. This allows for continuous tracking of energy consumption and carbon emission across company operators. For example, renewable energy uses Internet of Things sensors on its wind turbines to enhance their performance and efficiency. So Internet of Things technology is also utilized in various industries to monitor energy usage and emission in factories, warehouses, and offices, enabling businesses to make timely adjustments and optimize operations in real time. So together, these advanced technologies provide companies with the tools they need not only to monitor, but also to significantly reduce their carbon emissions, paving the way for more sustainable business practices. In the future of carbon footprint reduction is being shaped by emerging technologies and the extensive use of big data. So we said innovations like carbon capture, biotechnology, electric and hydrogen transport, and sustainable aviation are critical for reducing emissions high impact industries. All these technologies are transforming how companies monitor, track, and optimize emissions, and these tools enable precise monitoring, real-time analysis, and predictive insights, facilitating significant emission reduction across operation, which is crucial. So all these technologies advance and become more accessible. They not only help companies meet regulatory targets, but also open opportunities for cost savings and enhanced operational efficiency. So the rapid technological progress promises a more sustainable, low-carbon future, improving companies' environmental impact and brand reputation. But as we acknowledge the advancements in measuring and reducing carbon footprints, it is crucial to also consider the persistent challenges. Despite our progress, there's still a significant gap between measuring emissions and achieving actual reductions. Technologies like carbon capture can measure emissions accurately, but large-scale reduction remain elusive. So industries such as cement and steel largely depend on fossil fuels, limiting the effectiveness of other technologies. And additionally, economics and technologies barriers significantly impede progress. The high cost of electric trucks and carbon capture technologies prevent widespread adoption. Moreover, electric trucks face partial challenges because including insufficient charging infrastructure and limited battery life, which further complicate their deployment. So these challenges highlight the complex reality of carbon footprint management and underscore the need for comprehensive solutions that extend beyond current technological advancement. So as much as we may champion technologies like electric trucks, sustainable aviation, carbon capture, and economic feasibility of these technologies remains a certain critical barrier, because many emerging solutions are still in early stages and many require substantial investments in infrastructure and research and development to make them affordable and scalable, but most importantly, affordable. For example, carbon capture technology like direct air capture still requires vast financial resources to deploy effectively. While the potential of these technologies is immense, they are not yet commercially viable at the scale needed to reduce emissions drastically across all sectors. So this brings us to the critical point. The cost of implementing these solutions can be a barrier for many businesses, particularly small and medium-sized businesses that might not have the financial capacity to invest in new technologies. And governments and private sectors will need to collaborate to create financial incentives and facilitate the scaling of these technologies to make them accessible to all organizations. So while companies can do their part to reduce emissions, consumers' behavior plays a vital role in driving demand for sustainable products. As we discussed earlier, businesses can use carbon footprint data to inform consumers, but there is still a long way to go in shifting mass consumer habits toward more sustainable consumption. The greenwashing problem, companies face increased pressure to be environmentally responsible. There is a risk of greenwashing where businesses exaggerate or misinterpret their sustainability efforts to attract eco-conscious consumers. Without proper regulation and transparency, this can undermine genuine progress in reducing carbon footprints. And consumers, while some consumers are more than willing to pay a premium for environmental friendly products, many remain reluctant to change their habits, whether due to price sensitivity, lack of awareness, or convenience. Getting the mass market to consistently choose lower carbon options is a significant hurdle. So as we look ahead to the future of carbon footprint management, it is clear that the journey is just beginning. Emerging technologies, along with data-driven tools and innovators and in sustainability, are paving the way toward reducing global emissions. And this advancement give us opportunity to make real progress, but there are still some significant hurdles to overcome. And one of the biggest challenges is closing the gap between measurement and actual reduction in emissions. We also face financial challenges in scaling new technologies to a global level and the need to change consumers' behavior toward more sustainable choices. So to tackle these challenges, we need a collaborative approach. So governments, businesses, and consumers must play a part in creating a more sustainable future. Policymakers need to create incentives for innovation. Businesses must invest in technologies and adopt sustainable practices, and consumers must continue to drive demand for eco-friendly products. So on this side, I've listed some useful links to help you get started with calculating and reducing your carbon footprint. And these tools are a great way to measure emissions and understand your environmental impact. So why use these tools? We talked about it. These tools help you measure and track your carbon footprint and set achievable reduction targets and identify areas where you can improve, such as transportation, energy usage, or waste management. And by using them, you can better understand your environmental impact and take accountable steps towards sustainability. So as we wrap up today's session, we explored how to measure and reduce carbon footprint at both organizational and product level. Carbon footprint management is not just a challenge, it's an opportunity for businesses and individuals alike. So the journey to sustainability begins with understanding carbon emissions, By using the tools and methodologies as we discussed, organizations can identify areas for improvement, but the true impact comes from taking actions. So reducing emissions in supply chains. We talked about challenges in scope 3, adopting energy efficient practices and fostering consumers' awareness. So thank you very much for your attention today.